The purpose of this video is to expand on the recent video that I created on the mathematical impossibilities to evolution. Now, I showed this video to several university professors, including a professor of biology and a professor of mathematics. And both these professors suggested that I condense my thoughts into an article and submit it to a journal for peer review. So I decided to take their advice. I wrote an article, I submitted it to the Journal of Applied Mathematics and Physics, and it was peer-reviewed and accepted for publication. It should come out in late November of this year. And in this presentation, I'm going to outline these basic 4 premises of this paper, which I think are going to be fairly easy for everyone to understand. But before I get into the substance of this video, I need to dispel a very common argument that's used to attempt to refute probability challenges to evolution. Many who challenge evolution argue that you cannot apply mathematical probability to historical events. In other words, you can't look at an existing reality and determine after the fact or ex post facto whether or not it came about as a result of chance. Now, a common example that's used is the shuffling of a deck of cards. Every time a deck of 52 cards is shuffled, the sequence that results has an ex post facto probability that is extremely low. In other words, very improbable events happen every day. It's thus argued that random mutations can result routinely in very improbable nucleotide sequences and hence can explain the evolution of complexities. Now, this is a very common error of applied mathematical logic. It's mathematically certain that a shuffle of a deck of cards will result in an unordered sequence. If anyone shuffled a deck of cards with all the spades, diamonds, hearts, and clubs grouped together in order, you could conclude after the fact that the deck wasn't adequately shuffled. Now, ex post facto probability arguments are routinely employed in courts of law, and life and death decisions are made based on those improbabilities. For example, let's consider Jack Whiting, who is accused of pushing his wife off a cliff to her death. Now, Jack says it was an accident, but the prosecution argues that there were only 100 such accidental falls per year in the U.S. And since there are 68 million married women, this means that Jack had only a 1 chance out of 680,000 that this would have been an accident. Now, if this was the only evidence presented, no jury would be convinced that Jack was guilty. Jack might have been just as unlucky as the other 99 husbands in the country who lost their wives to falling off of cliffs. So in this case, ex post facto probability is a fallacious argument because only one event is considered. Now let's suppose that the prosecution came forward with documentation that 2 of Jack's former wives also died from falling off cliffs over the past 10 years. Any jury member would be very suspicious because no one could be that unlucky. So in this case, ex post facto probability arguments can be applied to determine if multiple separate events can be ascribed to chance. In this case, the probability of 3 events of this type to occur in one family in 10 years is about 1 chance in 2.6 quadrillion. So a random shuffle of a deck can result in any of trillions of possible sequences. However, 3 separate shuffles can't result in the same sequence 3 times. Now let's consider another example. Suppose someone flipped a coin 100 times and achieved 60% heads. Is that possible? The ex post facto probability of those being random fair tosses is 1 chance in 37. So it's possible that the coin was fair, but unlikely. But now suppose someone claimed to get 6,000 heads out of 10,000 tosses. That is impossible with a fair coin because the ex post facto probability is around 10 to the minus 90th. These calculations illustrate an important probability principle. The greater the number of trials, the more certain the outcome will be constrained to a random result. And this principle is mathematically described by the central limits theorem. Now, in my paper, 4 mathematical challenges to evolution are presented, and I'll address each of these. And I want to emphasize that each one of these challenges independently disproves the theory of evolution. So to those of you who might believe in evolution, if you think I'm wrong, you need to refute each and every one of these challenges. If any one of these 4 challenges is valid, evolution is destroyed. I've presented these challenges to several PhD-level mathematicians and biologists who believe in evolution, and to date, no one has refuted any of these 4 claims. The first challenge: all proposed pathways of macroevolution require the appearance of a directional pattern of mutations, and that pattern preferentially had to affect specific genes. For example, in the proposed evolution of the eye, a series of changes which creates a gradually increasing curvature of the retina is envisioned. Now, in Nilsson and Pelger's 1994 article, it's claimed that the vertebrate eye could have easily evolved from a flat, light-sensitive spot in 364,000 years. All they consider is that natural selection could favor an incrementally increasing curvature of the retina in 1,829 steps. They didn't even consider the odds of those 1,829 steps randomly appearing in a population. So here's the likelihood of those mutations appearing in a population. And I've made some reasonable assumptions, and I've employed the binomial distribution formula. The odds of these steps appearing in a population is about 1 chance in 10 to the 1,423rd power. Now, even though the numbers in this calculation might be disputed, it is clear that the probability of such a pattern of mutations appearing in a finite population over a limited number of generations can be rounded off to 0. Again, think about achieving 60% heads with 10,000 coin tosses. With mathematical certainty, random mutations will not deviate from a predictable random outcome to preferentially affect specific genes. Virtually every proposed pathway of macroevolution requires that specific genes be affected more than other genes. In other words, the mutations that drive evolutionary pathways could not have been random. Now, the next challenge I'm going to talk about is the widespread phenomenon of molecular convergence. This refers to similar DNA sequences of different species that can't be attributed to a common ancestor. For example, the genes that encode for the protein prestin, which is essential in echolocation, are similar in dolphins and bats. The 3 auditory genes of echolocation are composed of about 20,000 specific nucleotide bases, and these genes are believed to have evolved separately in at least 3 independent lineages. Now, the existence of these convergences can't be attributed to selection of random mutations. It's mathematically certain that a random process can't result in identical outcomes if the number of possible outcomes is too great. Now, this principle forms the basis of cybersecurity and protects billions of dollars from theft. The reason someone can't steal money from your bank account is because it's too unlikely that he'll correctly guess encrypted passwords. And this identical principle is also used in courts of law to determine if a suspect's DNA links him or her to a crime scene. The only biologic reason why a person's DNA can't match the DNA of someone else is the mathematical improbability that it'll match. And that calculated improbability is used as a gold standard to prove guilt or innocence. Now, how does this relate to convergence? Some might say, but what about natural selection? Natural selection can't act on a mutation that doesn't appear in the population. In considering the origin of molecular convergences, the creation of just 100 identical nucleotide sequences can occur in specific genes in different lineages by chance. And this is because the number of combinatorial possibilities of 100 nucleotide sequences is about 10 to the 60th, or about the number of elemental particles in the solar system. A similar comparison can be made by determining if a student has plagiarized an essay written by someone else. If the text is sufficiently similar, he's guilty. And this judgment is determined by the extreme ex post facto improbability that his words will coincidentally match the words of someone else. Now, this principle is universally understood and accepted without doing any mathematical calculations. The next mathematical challenge is the coevolution of complex integrated parts. Now, this refers to the creation of multiple independent parts that results in functionally integrated systems. Let's consider Jack Whiting, who was accused of murder in the previous example. The prosecution discovered that his previous 2 wives had also fallen off cliffs. So the evidence against Jack mounts. Now suppose that the prosecution produced evidence that Jack took out a large life insurance policy on the wife 2 weeks before she died. And another witness came forward and testified that Jack's wife was afraid of heights and would never have gotten near the edge of a cliff. These facts would have functionally integrated meaning to the case and would be used as further evidence that Jack's guilty. So with each line of corroborating circumstantial evidence presented, the probability that all of these integrated factors can be ascribed to chance diminishes. So in this manner, circumstantial evidence is used to convict or exonerate suspects by ex post facto probability arguments. Now, complex integrated parts are ubiquitous in biologic systems. The evolution of the eye includes much more than a curved retina. A system of integrated parts includes an iris that reacts to light, complex eye fluids, biochemical systems of vision, an optic nerve that needs to incrementally increase in size, a transparent lens with a specific microanatomy, occipital lobes of the brain to translate binary code into 3D images, a transparent cornea, tear glands and ducts, muscles to move the eye, and other anatomic endowments. Now, this obstacle is often dismissed because it's argued that the eye could function with very few of these integrated parts. But this begs the question, how could random mutations affect specific genes to result in a functionally integrated outcome? In the previous calculation of eye evolution, the probability would need to include not just the likelihood of the origin of an increasingly curved retina, but of all functionally integrated parts. So if just 10 functionally integrated components of vision are considered, this could result in a calculated probability on the order of 10 to the minus 14,000th power. Now, the next challenge is the nature of coded information. In recent years, the characteristics of DNA are being increasingly compared to informational systems of binary code of computer software. The nucleotide sequences of DNA are characterized by overlapping messages, data compression, and intricate algorithms, with long strings of nucleotides that control other segments of code. Many of these sequences are polyfunctional in nature. Now, the neo-Darwinian synthesis proposes that DNA can be incrementally improved. This presumes that single nucleotide substitutions can impart gradually improving functionality. But with an understanding of the nature of coded information, this is clearly impossible. The meaning of a sentence can't be gradually modified by random substitutions of individual letters. And in biologic systems, multiple nucleotides must be changed before natural selection can act. Now, some have suggested that multi-base pair mutations could have occurred, like inversions and frame shifts. Now, this proposal only magnifies the improbability barriers. Look at the size of the human genome and consider the fact that only about 150 point mutations per generation occur in an average birth. This means that the probability of the changing of just 10 nucleotides of human DNA to a specific result at given birth is about 1 chance in 10 to the 99th power. Now, in perspective, this is about as likely as selecting a specific atom in the known universe and dividing that by a factor of about 10 quintillion. Many proposed evolutionary pathways focus exclusively on patterns of phenotypic change in successive generations. These arguments are identical to those used in the 19th century, and they ignore the molecular basis for such changes. With our current understanding of DNA and the particulate nature of inheritance, virtually all proposals of complex evolutionary change decisively fail. Thank you for tuning into this video. For further information, I hope you'll go to my website and download a copy of the paper that I've just discussed.